Hello, everyone. Today we are going to understand the concept of the center of mass. This video will help you learn about the center of mass in a simple way by focusing on a two-particle system. Let's begin our journey. Here we have two friends, Alex and John, who want to ride the seesaw. Alex weighs 90 kilograms and John weighs 50 kilograms. It seems Alex is a bit heavier than John. Let's see what happens when they get on the seesaw. The distance between John and the fulcrum is 10 meters. The total distance between Alex and John is 20 meters. As you can see, the seesaw tips downward towards Alex because he weighs more. If we want to balance both of them like this, what adjustments can we make to achieve that balance? How can we stop the seesaw from tilting towards Alex? Let's think about it. This is where the concept of the center of mass comes into play. The center of mass is the weighted average position of all the mass in a body or system. It's the point where an applied force causes only straight line motion without rotation. The center of mass depends on the object's shape and mass distribution. In our seesaw example, the center of mass plays a key role. The seesaw acts as a lever with the fulcrum at the center. To balance the seesaw, the torques or rotational forces on both sides must be equal. The heavier person, Alex, needs to sit closer to the fulcrum, and John, being lighter, must sit farther away. Mathematically, we can balance the seesaw by ensuring that the product of mass and distance is equal on both sides. In this case, we use the formula m1d1 equals m2d2. Let's calculate the correct distance for Alex to sit using this formula. Here's the formula again. m1d1 equals m2d2. We know Alex weighs 90 kilograms, John weighs 50 kilograms, and John sits 10 meters from the fulcrum. Solving the equation, we find that Alex should sit 5.55 meters away from the fulcrum. When Alex sits 5.55 meters from the fulcrum, the seesaw will be balanced. If the center of mass is directly above the fulcrum, the seesaw will remain level. If not, it will tip towards the side with more mass or torque. In conclusion, we've learned that to balance the seesaw, Alex must sit closer to the fulcrum at 5.55 meters, while John remains at 10 meters. This way, the seesaw remains balanced with equal torque on both sides. Thanks for your time and keep learning.